Lee. What? Are you speaking English? I can't hear you.
He's messaging Andrew.
Andrew? Why Andrew? He's here?
I called him in before.
How much?
Can you write the title down, please? You got that? Continue. Yes? Okay. So, I have some formulas to do. So, if you have different charges and you put them together in different ways, you'll get different fields. And we have to look at 4 types. And one of them we've actually seen already. So the 4 different types of fields are, what field do we get when we have 1 point? What field do we get when we have like a sphere point? What field do we get when we have 2 plates? And lastly, is what we actually did last time. The picture was, what field do you get when you have a dipole, which means a positive and a negative charge? And you actually drew that one last time. So let's have a look at the 4 types. So the first type we'll do, I think, is a point charge. If you have a positive point, the field is going outwards, and if you have a negative point, the field is going inwards. And the arrows get bigger or smaller as you move out. Smaller. I should say that they like this question in the exam for like 2 marks. They say draw the electric field for a blank. So this would be draw the electric field for a negative or a positive point charge. So can you draw this in your book, point charge?
Nice bag.
It is a nice bag.
Yeah, it came with that icon.
Not bad. Continue. €3. Almost as good as the granola bar offer. Right, continue. So the next one.
No, online.
Online?
China. They shipped it with a ship. They didn't ship it with an airplane.
Well, for €3 then. Okay, the next one now is spherical charge. This basically just means like lots of the same charge put together. So here it's like you have positive charges, grouped together. And in fact, you get the same diagram as previously. There's no difference. So the point here is that when you stick the charges together, it's the same thing. Yeah?
You stick the charges together.
The same field diagram. What's wrong, Fuang? No breakfast? That's what's wrong. Why no breakfast? Overslept? From high school? That will be soon, not today.
Fleming, what's the other guy's name?
There's another guy.
Fleming, and what's the other one?
Grip rule.
Yeah.
Just grip rule.
No, what's his name?
I don't know, some loser nobody knows. You know his name? No, the other guy he's talking about. I didn't think so.
Do we draw this?
11. What? Yes. Lee, did you draw this? Did you? Could you? Thinking about what? It's a circle. Okay.
So the first one was what type? Point.
Point of G. So why are you late? Went to bed late? Yeah, so yeah. Why did you sleep so late? Up all night eating pizza, was it?
Yeah, I had to stay up doing some chemistry class.
Oh no, everything is made clear and the truth comes out. Is the homework due today?
Yes.
I see.
One homework.
Oh, now this guy, he's screwed.
No, I did before the audit.
Oh.
Or 12.2.
Leave that. Yeah, well,
I honestly remember that I did it, but I don't remember where I did it. So she
this is me and you.
You said that she did the first 3 or 2
Yeah.
points.
Yeah. So she wants to play and talk today. I did it, but I don't remember where I did it. So if she asks me, I'll tell her I did it, but I don't remember. Because we did this 3 weeks ago. And now she's doing it. You can't really do it.
We'll see. Alright, next. So the next one is if you have parallel plates, what does the field look like here? Yeah, straight lines. Except it's a little bit curved at the end. But basically it's a field from the positive plate to the negative plate. That's really it. So nothing interesting here. So add that to your list of 4, please. Got that? You drew that? Can I continue to the next one? Nice picture. Lee, did you draw this? Did you really? Continue. Last diagram. Dipole.
You have to draw it again.
You know, it would make me happy if you did.
Have you ever been to Paris, the waterfall?
Yep.
Yeah, that's all I can do.
I have, yeah.
I think
Good, yeah.
how do you get there?
I'm sure there's a coach. But I don't know. I'd go somewhere else first because you have to pay to see that, I think.
How much is
You need to see the
€5.
waterfall?
I know, because it's on private property.
Oh.
it is. It's like
It's not a
estate.
public site.
It's like an
Why?
estate.
Exactly. It's some guy's estate. It's like his garden.
Why did the government allow this?
Private property is an important thing in the West.
Yeah, but it's a natural site. Why would they make it a private property?
He pays money, he gets it.
Yeah, he must have paid a lot.
Yeah. The ones that have lions and stuff.
In fairness though, you see there's the house and the gardens, and you know, it's very nice gardens. The gardens are very nice, and that would require a lot of money to maintain. Because the gardens, you know, apart from just regular cutting the grass, you know, there's lots of trees, lots of flowers, waterfalls, statues. These all have to be cleaned and maintained. So, you know, I doubt he's making much money from the ticket price, you know.
I think he's rich, like, you know.
What's it called?
He's that.
Powers Court, gardens and waterfall.
But where do you pay? Do you pay when you get there?
Ah, yeah. I think you pay at the house, I think.
No, it's their own thing.
Buses, no, you take.
You can take
You
a
take-
dart to break.
No, you take 24 and then you walk for 25 minutes. That's what they said to get you to Wicklow or something.
Once
Or
you,
you can
once
take
you have
the
have
dart.
Google Maps, of course, on your phone.
Yeah.
So once you have the destination, when you get off the phone, you can just walk then.
Yeah.
Get off the bus, you can just walk then. All right. Did you draw this again? Did you? Okay. Continue? Yeah. Okay, so equipotential, new term. Let me help explain that with a simple diagram. What is the formula for potential energy here? mgh. So, the potential energy here for all these different places, are they the same or are they different? They're the same. Why? Same height. So if I draw a line here, all of these are the same. Here, these are all the same. Now, of course, it's not the same as this. It's bigger or smaller. It's bigger. So all these lines here, these are all called equipotential. They're the lines where the potential is the same. They're a little bit like levels. So here this is low and here this is high. But everywhere on the line is the same because you only care about the H. So the definition of equipotential is the part of the space where the potential energy is the same. And that kind of makes sense when you look at the word. Equi, equal, potential energy.
That's of course considering that each thing has the same mass.
Yeah. So in a moment we will draw these for your diagrams you just made.
Does it have nice restaurants too?
Yeah. I think it's called like Salt and Pepper Restaurant or something. No, it's nice.
But it's not a very nice day to go out today.
Well,
And it's a nice garden. One of the teachers proposed to their partner in these gardens.
partner?
Yes.
Like to
Propose.
buy.
Propose.
No,
I won't- I won't-
yes, to buy the garden.
No, like have.
I'm not.
Okay.
I'm deliberately not saying gender so that you can try not to give you any clues, so you can try and figure out who it is.
One of the teacher proposed to their partner in that garden.
What's wrong with that sentence? It seems straightforward.
Proposed.
Oh, okay, okay.
A bit slow this morning. So it's a nice garden. You don't just propose anywhere. There has to be a minimum standard.
One of the teachers.
Yeah.
That's it.
No.
No, the other Steven.
I won't tell you who.
Ah,
Actually, I don't know where he did, so I don't think it's him. Oops.
yeah.
Well,
the
he-
woman wants
yeah,
propose. Marry me.
And not in the West, anyways. Culturally, maybe it's different somewhere else. Okay. Did you write this down? So can you go back to your 4 pictures, and I want you to add in the equipotential line. So what was the first of the 4 diagrams? It was the point. Anyone think they might know what the equipotential lines might be? They're circles. So here the potential is the same, here it's the same, here it's the same. Can you add these to your diagram and make sure you write in that they're potential energy lines? So for example, something that is here, and something that is here, and something is here, these all have the same energy. This is a little bit like what you do in chemistry, isn't it? Or maybe you haven't done it yet.
Yeah.
Have you done energy levels?
Yes.
You have? Great. Now, for the second diagram, the sphere, what do you think? The same.
But like, it's not just a circle.
I'm talking about.
Like show it in 3D.
I suppose in 3D they're spheres. Does anyone know the word for when you put one circle inside another circle inside another circle? Overlap would mean that you have to meet.
Pomegranate.
Pomegranate?
Yeah.
No, that's a fruit. A delicious fruit, but not the answer. Does anyone know this word?
Enter something.
Pineapple? Pie? Ah! That is not used for shapes, that is only used for like people. Pile on the people, pile on the cars. What?
They're like when you put a circle inside the circle.
Oh. Are you okay? What's wrong?
Yeah, and then she's like, wow, you said you don't do that for shapes, you only do that for people.
Yeah.
What do you mean by four people?
Huh?
What do you mean by 4 people?
Like rugby game. The players pile on each other.
Okay.
Yeah. Or cars. There's an accident. A car pile. I don't get you guys. Anyways, the word is when one circle is inside another circle, concentric. Never heard of it? Yeah. And you don't use this word for people. So you don't say the people were concentric.
You can say the
Who
people
always
are
concentric.
You could say consensual, yes, but not concentric, no. Okay, the next one.
How do you spell it?
Do you
Yeah.
really need to know? Will you ever use it in your
Do we
life?
need to know?
No, this is a word that you might hear again in a maths or physics class, because it's a geometry word.
A circle inside circle.
Yeah, so you could, concentric circles.
Architect.
So that's
This is good for
concentric.
Yeah, no, this is a word you would need to know. Because you could have, like, for example,
Circle inside a circle.
but it doesn't have to be a
Sphere
circle.
inside a sphere.
Yeah, so it could be like
Square inside a
concentric
square.
pillars.
Also, it's shapes inside of each other.
Yes.
Not only circles.
No, only circles.
Similar shape. Inside each other.
Yeah, usually it's the same shape. Yeah. Okay, the next one, the parallel plates, isn't it?
That's what it means. Have the same center.
Yeah, that's true. Same center.
No.
Yes.
They
Yeah.
don't have
It
to.
is.
No.
Yes.
They usually do.
No, they don't. If you put for a circle, yes, but okay, yeah.
You were just
So
a
your
rectangle.
background was kind of.
Not going to win any art prize at Griffith Art Fair. Parallel plates. What do we think the potential lines might be? No, that's what here. They both did the
It's
exact
not
opposite thing.
it's
He's
not
like, they're like this. And he's like, like this.
Horizontal line.
So,
It depends on.
well, in my picture here, the potential lines will be horizontal lines. Can you add that to your diagrams? These are the potential energy lines.
For
Parallel
I
plates.
drew like this.
I can't believe you.
it was spherically similar.
Circle.
Dude, I just said it's the same as the first one.
Okay. Did you go to the Griffith art thing?
I will later, I think.
It closes today's the last day.
Oh, I better go today.
And you know what?
What?
They have free drinks.
Drinks or
Wine.
drinks?
No, drinks.
Oh, nice. I'll be there.
What then?
Huh? Free booze.
No! You
Where?
ruined it.
What?
He's underage.
Oh, is he? Oh, you're 17?
No.
Yes.
How was that? What the
She was there since she said it.
Nothing.
Free drinks at the art show.
Where's the usher?
I don't think they
It's
are
above the
giving you-
canteen, I think.
They would ask you for your ID, obviously.
But she's over 18.
No.
Yeah, so she'll pass.
That she looks like.
But
So,
she doesn't look
But
like
it doesn't
you.
matter. Once you have your ID.
But I don't have ID.
Ah!
yeah, that's
I
really
don't
She
know.
lost the whole-
They check everyone there and then
Gone
But I
forever.
have passport.
Ah, that'll do.
Yeah, they told you.
Yeah, I have with me.
You
Right
do?
now.
I can drink.
Yeah.
What is it? Oh yeah, you have to get the okay, never mind.
Yeah. Free drinks later.
And
I'm so
there's a picture of, there are two pictures that are really, really, really nice.
Top class model.
Yes, I heard there are some interesting models for some of these pictures.
Yeah,
Yes.
on the right.
Yes, yeah. It's what you might call alternative beauty, not mainstream. Mainstream, so
They're selling them for 140 euros.
180, please.
No, the big one is for 180.
100
Ours are small.
240.
No, you can get anyone printed to any size.
Oh,
Yeah.
and mine got bought.
And can
Sure.
they blur out faces if you pay extra?
People just walk past by and go, oh, this is.
Do you know they're in some of the pictures in the art show? Oh, we'll have to look later. Apparently they're in two of the pictures. I know, I can't believe it.
Just don't look through the book.
Is the usher just for me?
Yeah, anyone can see it.
Actually, look through the book, go to Basil's page. Look at the last picture.
Is it inappropriate?
No, it's so creepy. It's the creepiest thing I've ever seen.
I'll have a look later.
No means yes.
I'll have a look later. Right, just before continuing, again I'll say they like asking this in the field question in the exam where they say draw the field and the potential lines. Okay, so there's only 4 possibilities. The one they usually pick is the point for the exam.
What about Dipole?
I can show you the last one, but I don't think they'll ask it because it's a little bit too difficult. But this is the last one. Positive, negative. It's like this, isn't it? Yeah. Well, first I'll just draw the field. Let me think. And then it kind of scoops around. Well, I know it's ugly. Sorry, ugly. Now, any ideas on what this one looks like?
circles that
No.
Oh,
Yeah.
No.
But yeah.
They overlap.
Well,
No.
let's start here. It'll be a semicircle here,
And then it goes and covers.
but how do we continue it to the left?
Oh,
And there's a semicircle here,
And then,
In the middle.
plates.
huh?
Plates in the middle.
Straight?
Yeah.
Oh.
No.
Other.
I got
No.
remote.
And then line.
They like cancel each other, so they become vertical lines.
Like this?
Yeah.
Yes.
And then we.
Yeah, roughly. I don't know. I think I have a feeling it might curve in a little bit. I think so. Yeah.
But they're connected. And then
Yeah. And
there
then
lines in the middle.
oh, kind of like this. It's a bit hard to draw. That's why they've never asked this, and I don't think they will ask it in the exam. It's a little hard to draw. But anyway, can you just add that to your diagram, please?
You're wrong.
Am I wrong?
Yes.
Good. Show me the picture. Whoa!
Makes sense.
No, it doesn't.
Yeah, the pictures were at the art gallery.
No, give me.
Do they overlap?
Fudge. I tried to turn it upside down and decided to fix it for me. Yeah, sorry, I'm stupid.
Don't call yourself that.
No, it's okay. I can handle the truth. It's okay. It's important to accept when one is wrong.
The first step is acknowledging your
First step is acknowledgement. Yes. Oh, this is ugly. Makes me sick. Right. Sorry, the potential line should look like this. I know.
No.
Yeah.
No, those are the.
Oh yeah, sorry, they're the field lines, which I'm just redrawn. Yeah.
Yeah, so they overlap.
No, my mistake was when they don't click together.
Oh.
That was my mistake. So they are circles, but they're not circles that click together. Yeah, and then there's one here.
Line.
Yeah. It's ugly. Here you go.
I'm just thinking.
Yeah.
This.
Can you draw that in? These are the potentials. What are you asking, Faisal?
If they're different charges.
Oh yeah, it won't be symmetric, the picture.
Yeah.
You mean like if there were two positives here?
Yeah.
Yeah, it'd be different, yeah.
And even the
Firstly, that line will be gone because that is the lowest potential
Will
energy.
it be in the middle?
Oh, this is the.
For this one.
Oh, this is in the middle, yeah. But in the case when you have two, then I think this line gets moved to like
I
here.
think it's what you drew.
No. Anyways, can I continue? Did you draw that? Continue? Not yet? I thought you had plans to GF today, no?
Yeah, that's what I'm asking about.
At 1 o'clock? Your plans are at 1 o'clock? Okay.
Because it closes at 9, and I don't think we need like that much time.
What closed at 9?
The thing that did.
Yeah, you can have class at 1 and leave at 2, no?
The same charge.
Good. That's what I drew. Oh, the same charge. Sorry, I understand what you mean now. Yes, I was drawn plus plus.
Yeah.
Or minus minus. Yeah, this is not what you get in the exam. They like to keep it simple and just say point charge. Huh?
Sure, I like to keep it simple.
I suppose simple is a relative term. Less complicated? Alright, continue. Now, how do we make an electric field between two plates? I wonder if anyone knows.
We charge them with electricity that are passing through opposite directions.
Yeah, basically just connect the two plates to a power supply. This plate will become positive, this plate will become negative, and then what do we get in between? We get an electric field. It's helpful if it's a vacuum as well, although not necessarily this helpful.
If it's a vacuum.
Between the plates.
But will there be any current running through the circuit?
Yeah, because
If it's a vacuum,
yeah,
how will the particles move between the plates?
it's not, but it's a field that's moving between the plates.
No, I'm asking about the current.
Well, vacuum or no vacuum, the plates aren't touching, so. You know what I mean?
But if there was air, then the air can be a medium.
And this is what you don't want. You see,
But if you don't have a medium, then will the current go through? That's what I'm asking.
Current isn't the...
No current in the medium, they're electrons, they have to move somewhere.
you know, it's not it's not the electrons that are moving between the plates, it's the field around the electrons that are on the plate. So I still might think there might still be a current showing up if you connect an ammeter, but I don't think the electrons are physically moving between the plates. I think what's happening is there's just a electric field around the electrons that extends out from the plates. Do you know what I mean? So it's important that the plates are at least close together.
Yeah.
But I know if the plates are touching, or for example, if you like connect a wire between the plates, then you don't get the field. So I think it's almost like you're trying.
It's like a closed circuit. If you connect something between them.
Yeah, then it's a closed circuit and you don't get the field anymore. Yeah. Anyways, this is how you make the electric field between the two plates. So my next question is, you want to make the electric field here stronger. So, what do you think the effect of the voltage is here? If we increase the voltage, what will happen to the E? Increase or decrease? What do you think?
Decrease.
If we increase the V,
Yeah.
we'll increase the E.
Make this bigger. This will get bigger.
Or if we get them closer.
Yeah, or if you want to make the field stronger, you can make the plates closer together. So, in other words, the distance here, if you make the distance smaller, you can make the electric field stronger if you bring the plates closer together. Which kind of makes sense because it's like you're making it more intense. So, when a current is passed through two conducting plates, separated a distance d with a potential volt difference V, then an electric field is produced. Does anyone know the formula for the strength of the electric field using this method?
Charge.
No. V over D.
Oh.
Because if you make the V bigger, you make the E bigger. If you make the D smaller, you make the E bigger. So the formula for this is V over D for the electric field strength.
This is electric field strength between two plates.
Correct. So I see Andrew didn't make it because he was up late, not fasting, huh?
Because there's no shop for chemistry.
No, I think Andrew's the type of guy that would show up for physics and maths and then ditch chemistry.
Maybe he's ditching physics. I don't know.
And he'll show up for chemistry. Ooh, yeah, no, that's possible too.
No, because you woke up late, like, if I go now, it's half a lesson of physics and like chemistry, might be a bit stressful.
Might as well just stay in bed.
I wanted to come and then skip chemistry.
Will you skip chemistry?
No, see, now we have math after. I'm saying this correct.
Oh, nice. I'm touched. Okay, you wrote this down? Yep.
Alright, my fucking book.
What's... Oh my goodness, Lee is writing something! Everybody, this is extra important. Yes? Okay. So, next one is, if you have a charge Q, and you have your electric field, does it get stronger or weaker as we increase the distance out?
What gets stronger?
The electric field. Weaker.
Yeah.
So in the formula for E, we think there should be an or in it on the top or on the bottom.
Or?
Yeah, like or being the distance between.
Bottom.
Yeah, bottom somewhere, because as the or gets bigger, we're expecting the electric field to get smaller. And then what about if I have a bigger charge here? Do I make the field stronger or weaker?
Stronger.
So then there should be a Q in the formula, maybe somewhere on the top. Is it this? No, that's too easy, but it's not too far away. If you have a point, then the formula for the electric field strength is this. And this is a constant.
Is it on the calculator?
And this is on the calculator. So I'll write it down here. The formula is actually E equals 1 over 4 pi epsilon 0. This is just a constant.
How do you call it?
Epsilon.
What? Epsilon?
Epsilon or epsilon, depending on your pronunciation. Q over r squared. This is just a constant. Don't worry about it. It's just a constant. That's all it is.
What's the shape of the constant?
Epsilon.
No, it doesn't have. We have to write 1 over 4. Or
No,
epsilon.
some people just write for short K.
Yeah. Oh.
Q over r squared.
Okay, it means constant.
For constant, yeah.
Okay, okay, isn't it?
Good news is both this and this form is in the formula book with these constants. So you might as well just use this formula because this is in the formula book. Please do not mix it up with small k. That is a different constant.
So it's a constant on the calculator, K is on
No, this is the annoying thing. This k is not on the calculator. It's only in the formula book. This one is on the calculator. You can see it on your lid.
So if we want to use the K, then we need to memorize that.
Yes.
If you want to use the formula book K, yeah, well, this is in the formula book.
Yeah, what he means is that either ways we have to know the first one because that's the only way we can use it on the calculator.
No, because you can just type it in. Because it's in the formula book, the value of K.
Oh.
The value of K is in the formula book. It is not on your calculator, but it is in the formula book. And if I remember correctly, it's 8.99 times 10 to the 9, I believe. But I'll need to check the formula book. What's the units for K? Well, let's have a look here. What's the units for E? Here.
Newtons per coulomb.
Very good. And there's the K there. And the units for Q? Coulombs. And for R squared? Meter squared. So you have Newton meter squared per coulomb squared is the unit for let me write that again. Newton meter squared per coulomb squared is the unit for K here. It's just a constant. It's a very big constant. It's just a constant. Now, can you look at your lid on your calculator? What is epsilon 0 on your calculator?
32.
32? Let's check. Right, let's see if we get 8.99 10 to the 9. We do, I'm sure.
Just plus E and G.
The heck is...
Just plus E and G.
I can't, my calculator froze.
But it's no.
Which essay is this?
To draw.
Did you finish?
And this is why I don't do drafts.
No, but this one, like, I don't even
Draft, she asked for a draft?
because I know what
Yes,
draft
or-
She sent email saying send the draft. If you didn't send the draft, خلاص, you can't send it anymore.
So she won't ask.
She won't, no. Because she said if you don't send it now, on
How
that
many
day-
of you actually did send a draft?
No, she ended up Omar sending the draft tomorrow.
you-
Omar sent email to me.
I think because...
Wait, Omar's the one who sent the draft?
Going to send it.
Get us some.
Oh, going to. Okay, sure. Right, Newton meter squared per coulomb squared. And
Ask her, but she said she's not accepting anything. After...
I feel like she's gonna ask me anyway today. Like if I did something wrong. Whether I did something.
You ask what you want.
Yeah.
Thank you.
write this down and then go, okay? At least write the formula down. Now please note that E, in the definition I gave you what the epsilon zero was. That's built into the calculator. The epsilon zero is not Newton meter squared per coulomb squared. Why not?
Because it's a constant.
No, because in the formula, when you're using epsilon zero, it's in the denominator, whereas K is in the numerator. So the units are just backwards. So instead of Newton meter squared per coulomb squared, it's coulomb squared per Newton squared meter squared. Can I close this now?
Wait, did you say that it's K is 8.99
K.
I just said this a minute ago.
K is
That number there is for epsilon zero. 1 over 4 pi epsilon zero is the K. Right, so he's boogie outside the classroom.
You have class here?
No, I'm just hungry and tired. And I have corrections to do from the September exam.
Hungry, but not tired.
When do they get the results usually, like after?
I think in about a month.
A month. But like,
So
when do we
it's
get?
July.
When we finish, when do we get? Do we get ours sooner than theirs?
In August.
Because for us, if we want to go for DIT, we can't, you know about this. So, the sooner the better.
We can only give the results once Manchester have said the results are acceptable.
The IT don't care about much.
No, they do, because Manchester is the one who issued the certificate with the results on it.
On the
Yeah, but they
SPV
won't
website.
wait for us and keep like a certain amount of seats for in case.
That's why you get predicted grades sent to them.
But they don't. That's the thing. The IT doesn't care
No?
about that.
Did you have to interview?
No,
Did you have to meet with someone?
no,
I recommend doing that.
no. They don't. They don't. You don't get anything from the IT unless you finish and you show them your certificate and then they got the requirement for the grade.
I don't know how things work in your home country, but
No,
here...
this is here. This
No,
is
no, no,
here.
no, no. What I'm saying is here. Forget about what you were told. Forget about the way you think it is. In Ireland, knowing someone in a place
Yeah.
where you want to do business is very valuable. Very valuable. Meet someone. It doesn't matter.
Even here. Even here.
Yeah. Now, I'm not saying if you don't, you won't get in. But what I am saying is, it's helpful, you know. So, you can say, oh, it's Faisal here. Remember, I met with you on blah, blah, blah. So, am I in?
Yeah, actually, I've heard of it.
It's called networking.
Yeah.